Hello everyone. This is the lecture 12 for engineering economy. Um, okay, let me see how do I swipe to the next one. Okay. All right. So before we get started, the first thing is we are going to have a test um, on October the 5th. Okay. So and here are some things you need to know about the test. So the first thing is the test will cover what you have learned in chapter 1, 2, and 3. Okay, so you need to review these three chapters. And of course, we're going to have a class before the test, right before the test, to review everything. So make sure you don't miss that video. Okay, so that video should be on October 3rd, I guess. Yeah, so just one class before the test. Okay, and then you can access the test within the 24 hours of that day, October the 5th. Basically from the 12 a.m. to the 12 p.m. on that day. So um, no matter where you are on the earth, you can of course have your own time to access this test. And this is also the same setting for the final exam. So please just get familiar with how do you decide what time is best for you to get a test online. Okay. Um, Third, you can only submit the answers one time. Okay, you have only one chance to submit. Okay, everybody has one submission. This is different from the homework. Okay, so please be careful about the calculation, and then before you submit, just review everything. Make sure you got what you want. Um, Make sure you don't select anything. Okay, and the fourth, you need to finish the test within 150 minutes. That is 2 hours and a half. Okay, but if you have special needs and you need a extended time for that test, I think I have that approval email from the university, so I will check that email and see how much more time you need, and then I will set it up in the Canvas. So don't worry about that. Of course, you can send me a reminder if you're worried about me missing that external, no, I mean additional time for the test. And the test is not proctored, okay? So you don't have to find any proctor for this. And also you can use the slides, the textbook, the notes, scratch paper, and then calculators during the test. So basically, it's an open book test. Okay, open book, open note. So you don't have to remember all the equations, but I'm sure there are a lot of problems to solve. So you need to understand what we have talked about in the class, okay? So that you can quickly find what equation to use and quickly find the values for the letters in those equations. That's how you succeed in the test. Don't don't count on yourself reading the texts, reading the notes while you're doing the test and then solving the problem. That's not a time for you to learn. That's a time for you to show that you have already um, um, understand what we have taught in the class. Okay, you won't have enough time to learn and to read and then to solve the problem at the same time. Okay. All right, so let's get back to our class. So the concept of equivalence, as we started this new chapter 4, we talk about what is the concept of equivalence. Okay, so we said if the many multiple options of cash flows, if they can serve the same purpose, right? If they can have the same goals, then we say, okay, they are equivalent. And to be specific, if you have a cash flow, if you have different cash flows, the same purpose of them usually is to pay off something. Okay, pay off a loan, pay off a debt at some earlier time. Okay, like in this example, you have a balance of 17,000 on your credit card. Okay, and then now you said, okay, I need to stop this. I want to pay it off, and you want to pay it off in 4 months. But you have three options. You can pay the same amount every month, and then in the last month you pay whatever left. Okay. The second option is you just pay a bigger amount, but it's all the same every month, and you do that for 4 times, and then in the end you pay it off. And the third option is that you didn't pay anything in the first 3 months, but then you kind of saved a lot of money, or you withdraw, or you borrow money from your parents, whatever. You finally got a lot of money in the end, so you want to pay everything off just by the end of the 4th month. Okay, so these three options, they are equivalent because they do the same thing. They pay off the 17,000 balance, which occurred at the beginning of the zero, that's at the beginning of the first month. Okay, so they do the same thing. The three options are equivalent, which also means the three cash flows, they are equivalent. Okay, so for this one, this is somehow a future value, right? We said it's a FV or F, because that's a lump sum you pay in the future time. And also in the second option, we have the same amount, 4,357. We have the same amount every month. And in the later slide, we will learn that this kind of uniform series of cash flow, we call it annuity. And we simplify it as A. So these annuities and this future value, we said they are equivalent. Okay, they are equivalent because if you convert this annuity back to a present time, okay, you can calculate a present value of this annuity. And if the same thing, if you convert this future value back to a present time, you get another present value, and you will find out that these two present values are the same, and they are all same to the 17,000. That's why we say you can pay off that 17,000 by whatever by these two options and plus the first option. Okay, the reason why we say that is because you can convert the different cash flows back to the present time, and that present value will be the same for different options. So we can say this annuity, which is 4,357 every month for 4 months, is equivalent to this future value, which is 17,690.27 cents paid by the end of the 4th month. So the A and the F, they are equivalent. Okay? So this is a review of what is the concept of equivalence. And then we talk about like how do we calculate a future value given a present value, and how do we calculate a present value given a future value. By saying calculate or finding future value when given one given present value, what we mean is to find the equivalent future value of the given p-value. Okay? So we always use the concept of equivalence. Okay? So which means the money you paid now at present, it's equal to the money you get in the future time. But the exact amount could be different because of the presence of the interest rate. Okay? If there's no interest rate, if there is no inflation on the market, then $100 today should be the same as 100 years later. Okay? But the reality is not like that. We have interest rate everywhere, saving in the account, investing in the project, okay? And we also have inflation on the market. Okay, we have maybe 2% inflation rate every year. That's the reality. So your $100 today is not the exact amount. It's not gonna be 100 years later. It's gonna be more than 100 years later. Okay. So, but we still can say this 100 at present is equivalent to some amount bigger than 100 at 100 years later. Okay? Because we just convert this 100 by using the interest rate, compounding the interest rate for 100 years, and then we calculate the future equivalent. So when we say finding future value when given present value, actually we mean to find the equivalent future value of this present value. Okay? And we also learned how to find the present value, the equivalent present value of the given future value. Okay? And to be simple, I mean, I don't always say to find the equivalent f of given p. Usually I will say convert a value to some other value. So if given the p and to find out the f, I would say convert the p to a f. Okay? Because compounding is like a converting a value to another value at another time. So the easy way to say this thing is I will just say, okay, convert the present value to a future time, or convert the future value to a present time. Okay, that's how I say this phenomenon in the future classes. So don't be surprised if you heard me saying, please convert the present value to a future time. The real meaning is to find the future equivalent value of the present value. Okay? And also, I will use the word jump to represent the way the money get compounded 1 time, 2 times, 3 times, and then n times. Okay, so if I say the value has jumped 1, 2, 3, and n times, what I mean is it's compounded n times. Okay, so that's just some simple word I use in the future classes to represent this, the compounding and also the equivalent values. And then we talk about in the previous class we talked about how to calculate the future value from the given p-value and I and n. Okay, and so we said there are 2 ways. One way is the using of this equation, okay? But another simple way is to use the factor method. I like the factor method because you don't have to remember this equation. Of course, you don't have to deal with the order of like why do you open the parenthesis, when do you do the power, right? So I would like to use the factor method. But to use the factor method correctly, you need to write the factor itself correctly. Okay? So we said to find f equals to find f given p, so f equals to p times a factor, and that factor, how do you write it? The way you write it is you just think about, okay, I'm going to find what? Find f. So put the thing you want to find out at the beginning, and then give it a slash, and then what is given is after this, okay? So it's given p, right? And it's given I, and it's given n. N is the number of compounding period, okay? I is the interest rate. That's the way you write this term, or you write this factor. And once you have it written correctly, you can check the table in the appendix C to find out the factor value, okay? So, and to find out the table, you need to know what interest rate it is. In a given problem, you always know the interest rate. So find out that table first. And then you need to find out which column and which row, okay? So the column should be, look at this, what you are looking for, find what, given what. So you're finding f given p, so look at these headers, okay? So f/p, okay, that is the same as what you want. So this is the column you're looking at, okay? And then find out the row. The row number is the value of the n, number of compounding periods, okay? So if it's given in a problem like n is 4, and then this is gonna be the row you're looking at, and then you're gonna lock this cell, okay? That's how you use this table. And of course, you can use the same method for finding present value when given f, okay? And of course, you also need to learn how to write this factor correctly and find the right table by using the I and find out which column. So for this problem, it's to find the p given f, so that's this column, okay? You're looking at this column. And then you find out which row, which is the n, okay? All right, so in the previous class, we have learned to find out the p given f, to find out the f given p, okay? It's to converting the P and F, okay? And in this class, we're going to learn what is the annuity and how do we convert the annuity to P and F, okay? So what is annuity? Think about that. If you save the same amount of money every month in your saving account, that same amount of money every month, that is annuity. Okay, that's a uniform series of cash flow going into your account. Or if you got a paycheck from your employer, okay, basically you're gonna have the same amount salary, okay, right? And that same amount monthly salary is gonna be annuity. That's what we call an annuity, okay? So by definition, the cash flow diagram of the annuity will involve a series of uniform or equal receipts. It could be receipts, it could be expenses. It's just the same amount of cash flow occurring at the end of every compounding period. Okay, and we call each of amount annuity. So letter A is for annuity. Okay, and like what I said, that annuity cash flow should occur at the end of each period for n periods. So it occurred at a time point 1, that's the end of the first month, or no, I mean the first period. And then at the end of the second period, and then go on until at the end of the nth period. Okay, so the annuity always occur at the end of the first period and end at the end of the nth period. So this graph is a typical graph for annuity. Okay, so you will see the same length of arrows at the end of the first period, the second period, the third period, the n-1 period, and also the end of the n period. They are the same length, which means they are the same amount, okay? And then you label them the same amount. Here we label it as A, but if you have a specific amount, you just label it here, maybe 100 every month, okay? Or you can also just write A equals to 100, and everybody will understand, okay, that's gonna be 100 every period. Okay, so that you don't have to write the 100 like many times. And also, if you want to draw this type of diagram, you need to label out your I. Maybe your I is 10%. You just write it either beneath this timeline or above. Okay, and usually our problem will be to find out the present equivalent of this annuity, okay? Or we want to find out the future equivalent of this annuity, okay? And I would say you're going to convert the annuity back to the present time, or you want to convert the annuity toward the future time. That's the way I say that. But it is to find out the present equivalent and the future equivalent of the given annuity. Okay, and then let's take a look at these green boxes. So the timing when the annuity occur is very important. It is always at the end of periods 1 through n, including n. Okay, so if you have a cash flow diagram, let me draw it here. If you have a cash flow diagram, okay, 0, 1, 2, 3, 4, 5 years maybe, but your annuity occur beginning at the end of the second period, like that, and you don't have anything in the end of the first period or in the end of the fifth period, although we can say these three are still annuities, but you cannot use the equation we're going to introduce in a later slide for this problem. Why? Because it doesn't follow the rule. Okay, the rule is to use the method we're going to talk about later. You need to have your annuity begin at the end of the first period. Okay, which means you need to have something here. And also you need to have it through the n period, including n. So you need to have something here. In that case, you can use the equation in the next slide. Otherwise, it's another different problem. Okay? So be careful about this thing. And always check on the cash flow diagram if you have that annuity at the beginning. In the end of the first month. Okay. And the P always occurs one interest period before the first A. Okay? So that's just one period before. And then the F is always at the same time as the last annuity. So when you get your last annuity, that's where you can calculate the future value. Okay? So let's just see what kind of things we can do to use the relationship between the annuity and the future value and the present value. So there are 4 things we can do. And so the first case is finding F given A. Okay? So find the future equivalent value given annuity. In the real case, you can think, suppose you start to save $500 every month into your bank account. So $500 every month into your bank account, that's kind of annuity, right? And after 5 years, which means after 16 months, how much you can get out from that bank account? Okay, so that's a typical question we ask ourselves. If I save $500 every month for 60 months, given the interest rate of 2%, then I want to know how much I can get in after the 60 months. Okay, so to answer that question, you can use the equation for finding F given A. Very useful, right? The second scenario is to find P when given A. Okay, so suppose your parents want to put some money now to the bank account for your college life, okay? And what they want is you can get $500 every month from that account for 4 years for your college life. So you can get $500 out from that account, okay? But to have that $500 every month, your parents need to put some money at the beginning in the account. Okay? So they want to know how much they need to put into that account because there is interest rate of 2%. Okay, so the way they can answer the question is they want to use the method to find the present value given that annuity. Also very useful. And then the third scenario is to find the annuity when given a future value. Okay, suppose you need to save same amount of money every month for your retirement insurance plan, right? That's what we do. You save some money into that insurance plan, and then when you got retired, you can withdraw a lot of money from that insurance plan. Okay, so now you're planning on that, and then you say, okay, my plan is to get 1 million after 30 years hard work in the company. And then, so you got a future value you want. That's 1 million after 30 years, right? And then you already know that the insurance plan, on average, it will give you the interest rate of 5% every month. Okay, so the question is how much you need to save to your insurance plan every month so that you can get 1 million after 30 years. Well, to answer this question, you need to use the equation of finding A when given F, which is very, very useful for me. The last scenario is to find A when given P. Okay, think about that. Suppose your parents now they put 50,000 into your bank account. Okay, now, and they told you that that's all for your college life. Okay, so there are not more money they can spend on you. They just have that 50,000 now. So they put that in the bank and they tell you that, okay, that's all for you for your college life. So now you need to decide how much you want to withdraw from that account so that the money can be enough to cover the whole 4 years in the college. Okay, so now you want to know how much you need to you can withdraw. You cannot withdraw like 10,000 every month because that's the money is not enough. Okay, so you need to have a plan. And then to answer this question, you need to use the equation of finding A when given P. So these 4 scenarios are all very real and very useful in our daily life. So I think we have a very good reason to just learn how do we calculate the F given A, how do we calculate the P given A, how do we find out the A given F, how do we find out the A given P. So here are the equations. Of course, you can use the equation method. Okay, so to find the F given A, you can use F equals to A blah blah blah. But to look at this equation, it's just hard to calculate. Okay, hard to remember and hard to use. But luckily we have the factor method. Okay. So the factor method is easy to use, but the first thing is you need to learn how to write the factors first. Okay, so now let's just repeat how do we learn it, how do we write it. Okay, so the factor, you always want to put parentheses first, and then you think about what do you want to find. That's the letter at the beginning. So in this case, you want to find F. So it's F, and then slash, and then you put all the given conditions after this slash. And then so it's find F given what? Given A. So it's A, and you always know the interest rate and then the number of periods. That's how you write it, okay? Now let's practice this factor. So write the parentheses first, and then think about what do you want to find out. You want to find out the present value given A. So P is going to be the first letter, and slash. And then after that are the given conditions. So you are given A and I% and N. Okay? Now let's continue to practice this. So for the third scenario, you want to find A when given F. So you want to put A at the beginning, slash F. And then you also know the interest rate and number of period. Okay, now let's try this. So the case is you want to find A when given P. So A is the beginning letter. And then next, given P and I% and N. Okay, practice this. Pause on this slide and then try to write down the factor on the paper and compare if you got the same answer. Okay, that's very important. All right, and then okay, so after you know how to write this factor, the way to calculate the F given A is very easy. So F equals to, because you are given A, so it's A times that factor, okay? And to find the P when given A, so P is given, you are given A, so you put the A at the beginning, so A times a factor, okay? So if you want to find A when given F, so A equals to, because you're given F, so you put the F here and times that factor. And the same thing, if you want to find A when given P, so A equals to P, which is given, times the factor. Okay? And the way you find out the factors is the same. You first need to identify what interest rate. So you find this table from the Appendix C on your textbook, okay? And then you want to find out what is your question, what is the column. So if you want to find the F given A, you want to look at this. If you want to find out A given F, you want to look at this column. And then you're going to check the number of periods to find out which row you're looking at. And then you lock the factor value. Okay? All right, now let's look at the examples. So example number 1 is to, well, let's just read the statement first and see if you can understand what case it is. Okay? So a recent government study reported that a college degree is worth an extra $23,000 per year in income compared to what a high school graduate makes. So it said if you got a college degree, you're going to learn 23,000 more, earn 23,000 more per year than if you got a high school degree. Okay, which makes sense. And if the interest rate I is 6% per year and you work for 40 years, what is the future compound amount F of this extra income? Okay, so sounds like you have 23,000 per year as income, and that's the same amount occurred every year, so we can say that's annuity, right? And now you want to know what is the equivalent value F of that annuity. You want to know after 40 years how much more you can earn. Okay, how much more you can earn in total compared to a high school degree. Okay, so the first thing is you want to draw a cash flow diagram. Okay, so to draw that diagram, you need to have a viewpoint, perspective. So let's say the viewpoint is you save 23,000 That's the extra, okay? So we're just looking at the extra. So you save kind of like you can save 23,000 more every year into your bank account. And that account gives you I equals to 6% interest rate. Okay? So you can think of this problem as this. So you save the same amount of money every year into your bank account at an interest rate. So you want to know after 40 years how much you can get from that account. Okay? So let's draw this diagram. So you have your timeline starting at 0, 1, 2, 3, and then because it's so many years, so I would just represent the year in the between like that, and then you got 40, and before 40 you got 39. This is just a way to make it shorter, okay? And then because you're looking at this from your point of view, so you save 23,000 per year into the bank account. That money is out from your pocket, okay? So it's cash outflow. So it's arrows going downward. And also they're all the same length because they are the same amount. And it occurs at the end of the first year, and it continues until the end of the 40th year, right? And then you want to just write the A equals to 23,000 so that you don't have to label this amount for each of the arrow for 40 times. But you still want to write the I of 6%, okay, above or beneath this timeline. And your question is, what is the future amount of this given annuity? So your future amount is gonna be the lump sum money you can withdraw from this bank account. So that's gonna be an arrow going upward, but it's unknown, so it's a dashed line. And then you can write F equals to a question mark. That's the way you draw the diagram, the cash flow diagram, okay? Based on the cash flow diagram, now we can use the method. I would use the factor method, okay? So now we're finding F given A. So F equals to A times a factor. And that factor is what? To find F given A, given I, given N. Okay? And then you need to find out what is A and what is the factor value. So A is 23,000. That's given. And what is the factor value? So F slash A and I is 6%. You just write it there. And N is 40. Okay, so that's the factor you want to find out from the table. Now let's look at the table. So we said I is 6%, so we use this table from the appendix C. And then the problem is to find F given A. So this is your column, okay, F slash A. And also which row, because you have 40 years to compound. So N equals to 40, that's your row. And then you can look up this factor value. So 154.7620, that's the factor value you need to use. So you continue the calculation. 23,000 times that factor value you just found out from the next page, okay? So that value is 154.7620. 20. Use your calculator, do the calculation, and then you will find out the final result is 3,559,526. Wow, that's a lot, right? So please work hard on your college degree, because that will give you this much, 3.5 million more in the end of your 40 years of work. Okay, that's a lot. I'm so surprised. All right, so this is the first example. Okay, and then this is the second example. So still, let's read the statement and see if you can identify what scenario it is. Okay, a microbrewery is considering the installation of a newly designed boiler system that burns the dried, spent malt and barley grains from the brewing process. So it sounds like this is a new type of boiler which can save you some money, because you can recycle the whatever you produce or you have from your brewery business, right? The boiler will produce process steam that powers the majority of the brewery energy operations, saving. Look at that. So the new boiler can save you this much per year over the boiler's expected life of 10 years. So every year you save the same amount for 10 years. That sounds like annuity, right? If the interest rate is 12% per year, how much money can the brewery afford to invest in the new boiler system? Okay, so how much you can pay, how much you would love to pay for this new boiler, so that you don't lose or you don't pay too much. Okay, so the way you think that is, you save some money every year for 10 years. How much in the total you have saved? That should be the same as how much you paid at the beginning to buy it, right? Of course, you want to pay even less at the beginning so that you have a better deal, because you saved more, you paid less for it. But you have an upper limit of that payment, and that's what you want to know. So, at least you need to pay the same as what you can save in the future. That's the point, okay? So the problem equals to, you want to find out the present value of that saving amount for 10 years. What's the present value of that cash flow? That's your real problem. So that is to find P when given A. Okay? So still, the first thing is you need to draw the diagram, the cash flow diagram. And the way you look at this, the perspective is from your perspective. You're the brewery. Okay? So from the brewery perspective. Okay? And then draw this diagram. So we have a line, and then we have 0, 1, 2, 3, and then I don't want to draw the long line, so I will use this zigzag symbol to represent all the years in between. And then I got 9, and then I got 10. Okay, that's the whole timeline. Because you're looking at from the brewery's perspective, so at the beginning they need to spend some money, and then every year they can save some money. So the savings are kind of receiving the inflow, right? Cash inflow. So the saving of the 450,000 per year, it should be the cash flow going upward. So you want to draw the same length of arrows for all the 10 periods. And then you write A equals to 450,000, right? And then you say the I equals to 12%. And what you want to know is at the beginning how much you want to pay, how much the brewery want to pay. So you want to find out the present value. And the present value should be the money giving out. So it's going downward. So what is that? Okay, so it's to find P when given A. That's the scenario you're looking at. So you're going to use this equation. Okay, so P is A times a factor. Let's practice. The factor is to find P given A and I% and N. Okay, so what is A? A is 450,000, and you just use the values of I and N to substitute the letters. So I is 12%, N is 10. Okay, so now you need to find out the exact factor value from the table. So the table is the I equals to 12. That's the table. And then you want to find out the column. Column is to find P given A. And the row is N is 10. So this is your factor. Okay, so 5.6502. And do the calculation. You will find out the result as 2,542,590. Wow, that's so expensive, I would say. Okay, but that's the upper limit amount you want to pay for this boiler. Okay, so that what you gain from using that is equal to what you have paid. But if you are a good businessman, you can negotiate the price, and you might get a lower price than this, which means you pay less and you save more. Okay, that's a good deal. All right, what's the next? Okay, so now it's the example 3. Let's just read through it, okay? So you borrow 15,000 from your credit union to purchase a used car. And the interest rate on your loan is 0.25% per month. And you will make a total of 36 monthly payments to pay it off. So what is your monthly payment? Okay, that is very useful scenario when you're going to buy a new car. Okay, so this is actually to find out A when given P, because the money you borrow now is kind of present value, and then you want to know like how much you pay it back every month. That's the annuity. So that's this scenario to find A given P. The first thing is you want to draw this diagram, the cash flow diagram. And you can choose to use your perspective, of course. So your perspective to draw this diagram. So you want to draw a timeline. 0, 1, 2, 3 until the 36. Before that it's the 35. Okay, and then you borrow 15,000. So from your perspective, you get 15,000 into your pocket. That's the inflow. So that's arrow going upward. So it's like this. And that's the P equals to 15,000. Okay? And the I is what? Is 0.25%, which is pretty low. And also, what you want to know is how much you pay every month. So, and the money you pay is the money going out from a pocket. That's the cash outflow. So it's going downward. So you want to draw a dashed arrow for each period, okay, until the end. And then you want to say A equals to what? Because you don't know. So that is dashed. And then, so now you want to use this equation, okay? So A is P times a factor. That factor is to find A given P and I% and M. So what is P? P is 15,000. That's given. Times A/P. What is I? I is 0.25%. N is 36. Okay. Now you need to find out the table in Appendix C and find out this factor. Okay? So that table is here. 0.25% is a quarter, okay? And then you want to find out A given P, so this is the column. And how many periods? 36. Okay, so let's just see which is, so this is the factor you want to use. And that factor is 0.0291, which is 436.5 per month. So that is your monthly payment to that loan, okay? Which is very useful. All right, next. Now let's just, have a pause and then let's try to summarize everything we have learned until now. Okay, so we learned how do we find the future value given a present value. How do we find out the present value given future value? Okay, and then today we have learned how to find out the future value given annuity. How do we find out the present value given annuity? And also, how do we find out annuity given the future value, and how do we find out annuity given the present value? To me, it's just like to convert the value at different times to another time spot. Okay, so I always say convert this value to another value. And we learned the equation method. So these are the equations you can use. But we said we want to always use the factor method, okay? But to use the factor method, you need to learn how do you write the factor functional symbol. How do you write the factor first? So I want you to just look at this table and then try to write the factors, okay? And then I want you to practice that on this blank page. Okay, how do you write the factor for this one, and this one, and this one, this one, all of this, okay? So this page is for you to practice. You just make a pause and then fill the blank parentheses here and compare that with this page to see if you truly understand how to write this factor. Excuse me. Okay. There's the last case, okay, is called deferred annuities. Defer means it's delayed, means the annuity does not occur at the end of the first period. Okay, so just to think about the regular annuity, we draw it like this. And the rule is the annuity occurs at the beginning of the first, at the end of the first period. Okay, and we call it ordinary annuities. That's the annuity problem we have seen. But now we want to learn a new type of annuity problem, which is called deferred annuity, which means the first annuity itself, it started at the end of not the first period, but some later time. Because it's some later time, so we say it's J plus 1 period. Okay, we don't know what is J. It could be the 6th period, it could be the 60th period. It's just some later time. But we know it's not at the end of the first period. So for this type of annuity, we call it deferred annuity. Okay, and then for this type of annuity, we have a new equation to calculate the present value. Okay, so if you have some delayed annuity, it's not happen at the end of the first period, but at some later time. How do you convert that back to the present time? I mean the time 0. Okay, so this is the equation you want to use. And look at this equation. It's A times P slash A I% N minus J. Okay, so now you need to know what is N and also what is J. So what is J? J is here. J is just the you need to know like when the first annuity occur, and that time minus 1 is gonna be the J. Okay, so don't worry if you don't understand that, and then we can learn that from this example. Okay. Okay, but after that first factor, you also need to find out a second factor, which is P slash F, I% and J. So very important, you need to find out the J. Okay, let's read this example and you will know what do I mean by find out the J. So suppose that a father, on the day his son is born, that's the present time, that's the 0, okay, that's time 0. So the father at the beginning wishes to determine what lump amount would have to be paid into an account bearing interest of 12% per year, so that it can provide withdrawals of 2,000 on each of the son's 18th, 19th, 20th, and 21st birthdays. How sweet it is. So the father wants to save amount of money at when his son was born. And then what he wants is after 17 years, at the end of the 17 years, his son can withdraw some 2,000 from that account on his 18th birthday. And then he could do the same thing on his 19th birthday and 20th birthday and 21st birthday. So this is a deferred annuity problem, because that annuity, the 2,000, the same amount every year, that does not happen at the end of the first year. Okay, it happened at a later time, which is the 16th birthday. So now let's just draw this diagram. Okay, so you can look at it from the viewpoint of the father. So from the father's point of view. And then let's draw this timeline. So 0, that's when the son was born. 1, that's his first birthday. 2, second birthday. third birthday, nothing happened because the father wants him to withdraw the money from at the 18th birthday and 19th birthday, 20th birthday until the 21st birthday. Okay? And then so if you look at it from the father's point of view, which is the same as the bank's point of view, of course. So the father will spend some amount out of his pocket. Okay, so he wants to know how much he has to spend at the beginning. So that's a dashed arrow going downward. Okay, that's the P. You don't know. So it's a question mark. And starting from the 18th birthday, his son will receive 2,000, okay, every year after the 18th birthday. So that's a receive. The money you receive is gonna be the money going upward. The arrow is going upward. Okay, so it's gonna be small arrows like this, but the same length for the 4 years. And then that's the A, and A is 2,000. Okay, and you know that the I is 12%. So now you need to know, okay, what is the P? And to know the P, you want to use this equation, okay? But the first thing is you need to find out the J, all right? So what is the J? So compare this where the first cash flow, first annuity happened. That's what we call J plus 1, the time J plus 1. And then compare that to this. Look at that. Okay, so this is the thing you're looking at. That's the first annuity. And the number of periods is 18. Okay, and 18 is what? Is in this formula, I mean in this general diagram, it's gonna be J plus 1. Okay, so if 18 equals to J plus 1, what is J? J is gonna be 17, right? So J is 17 in this problem. That's what you know. Okay, so now you can use this formula. So P is A times P slash A, okay, I%, N minus J. N is what? N is 21. J is what? J is 17. Times another factor, which is P slash F, I%, and J, which is 17. Okay, now you understand why do I say J is very important. And you got to find a way to find out J. And the way you find it out is you to compare this, the first annuity, when it happened, and use that year minus 1. That's your J. Okay? So let's continue. A is 2,000. And the first factor is P slash A. I is what? 12%. 21 minus 17 is what? Is 4. Another factor, P slash F. I is 12%. N is 17. Okay? Now you just need to check the table. Okay? So the first factor is P slash A. So to find P given A, that's the column you're looking at. And number of periods is 4. So this is the row. Okay? And so this is the first factor you're going to use. So you just write it down here. It's 3.0373. Second factor, P slash F. P slash F. So this is the column you're looking at. And N is 17. Okay, so 17 is here. So that's the second factor's row you're looking at. So this is the factor, okay, the value of the second factor. So it is 0.1456. So calculate that. Then you will get 884.46. Sounds a good deal. Because your father only needs to put like lower than 900 into the bank. And then after 18 years, you can get 2,000. Wow, every year for 4 times. Sounds a good deal for me. Okay, so plan your saving as early as possible, right? But this problem is what we call deferred annuity. So the tricky point is you need to find out the J, okay? And once you find out the right J, you don't have any problem calculating it. Just use this equation. Okay, so that's it for today. And don't forget about the test number 1. And we will have a review class before the test, so don't miss that video. Okay. All right, see you next time.